Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Did you remember what were we discussing yesterday? I think we were discussing about retrosynthetic analysis, how retrosynthetic analysis is important. What is the purpose of introducing retrosynthetic analysis approach at T.Y.B.Sc level? How it is innovative, it is creative, imaginary, how it can increasing your imaginary logical thinking power, how it is developed, how to nurture your thinking power. That is the main object or the purpose of this chapter, to introduce you the basic principle of retrosynthetic analysis. Once you have read and understood it, you will be on the way to designing your own organic synthesis. So this is the main purpose, main aim of this chapter, to introduce at T.Y.B.Sc level, because one separate course is there when you will take your higher study, higher education in MSc level. I think for MSc second year there is one separate course is there, designing of organic synthesis by retrosynthetic approach. There is one very good book, reference book I am talking about. I am not talking about the textbook over here. For this, those are the advanced student, advanced learner. Those are highly hungry for acquiring, for getting knowledge. They should refer the book, which is very good book, beautifully written. The name of that author is Stuart Warren. It is a very good book you can use while studying for this retrosynthetic analysis. So what are the points we have discussed so far? First one, the title of this chapter itself indicate that the retrosynthetic analysis. Retrosynthetic analysis, there we have learned the definition, the concept, how it is a creative chemistry, is all about a creative science, and all those things we have learned. But let me tell you, the retrosynthetic analysis means what? The process of breaking down the target molecule into convenient starting material using disconnection and functional group interconversion is known as retrosynthetic analysis. Or another way we can define it, an art of planning the synthesis of target molecule is called as retrosynthetic analysis. And second point, or the second important definition or the term we have learned, that is RES, is nothing but as a retrosynthesis. Retrosynthesis means what? An imaginary but logical reverse chemical reaction which help us to reach the reactant starting from the target molecule is known as retrosynthesis. So that retrosynthesis is imaginary. So you have to imagine, but that your imagination should be correlate with the logical imaginary power you have to develop here. You have to break the bond in a such a way that we can make that bond. Then there are the different ways to break the bond on a paper, but while breaking that bond, you should keep in mind, so far you have learned number of named reaction, number of oxidizing reagent, number of reducing reagent, number of rearrangement reaction you have learned. By applying those reactions, those oxidizing reagent, those reducing reagent at appropriate or in a proper way to make that bond in a simplified mechanism or the simplest modification, you have to think in that way. You have to develop your imagination power, how we can synthesize that target molecule by knowing the way of making that carbon-carbon new bond. There are different name reactions. By applying those, we can break the bond in such a way that, and after that we have learned one of the important term, that is a target molecule, TM. TM means what? The full form of that TM is a target molecule, and they are shown by the some of the frame numbers like TM1, TM2, TM3. So that is the numbering system we have used, or we are going to use in this chapter. But let me tell you the definition of that target molecule. TM means target molecule, the molecule whose synthesis being planned is called as target molecule, and that is represented by some frame numbers like or such as TM1, TM2, TM3, TM4, etc. Any target molecule you can write, you can show on the blackboard, so that becomes a target molecule with some of the example we have seen. Then next important term, and its a definition we have seen, that is D means disconnection, and that disconnection arrow, generally retrosynthesis arrow we have learned, the symbol of that disconnection arrow, double line and then arrow put it there. You can see that the disconnection arrow, and it is a essential and the important step involved in the retrosynthetic analysis. It is a reverse, and the arrow, meaning of their arrow could be made from, means your target molecule while showing disconnection arrow, meaning of that arrow could be made from, means this molecule, this target molecule, you can prepare, you can obtain, you can derive from this. So that is the meaning of that disconnection arrow. And by taking the suitable example, there we have seen tertiary alcohol. First, while analyzing the target molecule, what are the main points to observe, to notice in the target molecule? First of all, see the target molecule, observe the target molecule carefully, and after observing the target molecule carefully, what is the first point to observe in that target molecule? You should recognize the functional group. As I already told you that there are number of functional group present in the organic compound, and those functional group, the name itself suggests that one of the functional group is interconverting into another. So one of the functional group can be obtained, can be converted into another functional group by using appropriate reagent, appropriate oxidizing reagent, proper reducing reagent, proper named reagent, proper acid or proper bases, by using those proper, keeping the proper reaction condition, you will get the desired product. So in that way you have to increase your thinking power, because that retrosynthetic analysis it will give your brain. You can use your brain in a such a way that you can train your brain. You can train your brain in a such a way that it can think in a such a way. So whatever chemistry you have learned, how to make molecule you have learned, but now it is a reverse of chemical reaction, as we know that in the retrosynthetic analysis, an imaginary but a logical reverse chemical reaction which help us to reach the reactant starting from the target molecule is known as retrosynthetic. So logically you have to think reverse or backward to reach the reactant starting from the target molecule. So in this way your brain, your thinking power is developing step by step in such a way that you are able to design your own organic synthesis. I already told you that the aim of this subject, the aim of this chapter is to introduce you to the basic principle of retrosynthetic analysis. Once you have understood it, once you have read it and understood it, you will be on the way to designing your own organic synthesis. So that is the main objective of this chapter. So far we have learned these are the term. Number one, that is retrosynthetic analysis. Second one we have learned retrosynthesis. Third one we have learned target molecule. And fourth we have learned that is disconnection, and that disconnection is represented by the symbol. This is the symbol generally representing that arrow. Disconnection means what? It is an analytical operation. It is an analytical operation, the process of the analytical operation which break a bond and convert a molecule into a convenient starting material by using or what we can call it as an analytical operation which break a bond and convert a molecule into a possible starting material is known as disconnection. And disconnection, the symbol of disconnection is this one, and the meaning of that arrow could be made from, means A could be made from B, or B could be made from C, or C could be made from suppose as a, let us see here, A could be made A could be made from B, or B could be made from C, or C could be made from D, or D could be made from E, or E could be made from like that F, or so on. So this way of planning this synthesis, these are the terms we have seen so far. Now let's look at the another important because we are learning or we are discussing the some definition and the term, some important definition and term involved in retrosynthetic analysis. Actual application we will see later on, but what are the requirement, essential point, essential terms required for it, that we are learning because it is a new topic to you, to the T.Y.B.Sc student, and that's why I am highlighting, I am repeating those terms again and again so that you must be familiar with those terms. What are those terms, their meanings, and I am trying to explain with the help of suitable example, so that by bombarding this word, by altering this word, you get somewhat familiar with those words, and you can use this word, you can understood this word, and you can use this word while in your regular or while in your future brightness or in your future study. So let's see the next. What is that? Synthon, right? Next one will be the synthon. Now it's a synthon. Synthon, it is a word, is what we can call it as a new terminology or the its definition and that term. What does it mean? With the help of the example, we are going to learn. Or here, first let me, whatever we have seen over here, S stand for as a synthon, right? This is a synthon. These are my short form synthon. So what do you mean by the synthon? What does it indicate? What does it mean? So that are the thing we are going to learn shortly, mean just now. So synthon, this is not the name of that soap. It is a name used in a retrosynthetic analysis. It is one of the important term used in the retrosynthetics. What does it mean? Here generally synthon means, remember, plus or minus, that type of the, after the fragmentation, after breaking or after the disconnection we have seen. Here we have taken as an example of tertiary alcohol. During that you might have seen there are, I am writing as a CH3 minus. One of the fragmentation we got there is a minus, means that carbon atom carrying as a negative charge. But let me give you here one example. Suppose let us see here one of the example over here. Suppose I have this one CH3, then here I am writing OH, then Cn, and again is a CH3, this type of the target molecule. Let us see, this is one of the target. I am taken this this is a target molecule. I am taken it is a randomly here. I am trying to explain you this, or let us see here, let me again what we can call it is here, let us see as a, suppose as a okay, then CS3 and CN, so that type of the thing I am writing over here. So this is a one of the target molecule. Let us assume that when I am breaking as a bond from here, because this is our, suppose as a as a, this is our TM, means this is a target molecule A, suppose, right? And after the disconnection, and this is a disconnection arrow, we know that disconnection means what? It is an important term involved in the retrosynthetic analysis, very important step in the retrosynthetic analysis. According to the definition of the what we can call it as this disconnection, and after the breaking of that bond, as we know that this bond is nothing but formed due to the sharing of electron. One electron is shared by this carbon atom and this carbon atom equally sharing, and after the breaking the bond is broken is heterolytically. When bond is any bond is broken, there are breaking are taking place. Two types of the fissions are occur by the covalent bond. One is called as a homolytic fission, or which is known as homolytic or the homolysis fission, and second one is called as a heterolytic fission. Heterolytic fission, homolytic fission, when the bond is broken homolytically or fission occur, it means that when they separate that two atoms from each other, they are taking one electron along with them, and that is called as a free radical, and that free radical are very reactive because they are the unpaired electrons are there, and as we know that unpaired electrons are highly reactive in nature. And now after breaking, but the bond is broken heterolytically, and at that moment, at that time, what is happening here, the sharing of electron, when the bond is broken heterolytically, whatever sharing of electron, that bonding pair is taking by only one atom, and it carries as a negative charge. When the electron goes along with that atom possess, that atom exhibit is a negative charge, and hence the other atom must be electron deficient in nature. They are the electropositive in nature, means we are placing as a positive charge, means after breaking this target molecule, you may get over here, you get here this type of the product. Here is a minus charge, here also has a Cn minus charge, sorry, here is a positive charge over here is a Cn minus. Means after the fragmentation, after the breaking the bond between that carbon and cyanide group, I got here one carbon atom is a positive, another one is a negative. That type of the fragmentation means now I am going to define the definition. Whatever fragmentation I got here, they are known as a synthon. This is known as a synthon. Negative or positive, it doesn't matter. After the fragmentation, whatever species are obtained, generally in terms of positively charged and negatively charged, means synthons are associated with polarities, that is called as a synthon. So in a retrosynthetic analysis, after breaking the bond, whatever compounds are obtained, that fragmentation is known as a synthon. Synthon are fragment of molecule which which are associated with polarities of positive or negative. Thus synthons are usually an ion produced by disconnection, and after the disconnection we are getting, this is a disconnection arrow, and after that whatever fragmentation species are we are getting, that are known as a synthon. Synthon are the fragment of the molecules. Suppose this is there, so these are called as a synthon. Or let me show you again this one, that is a cyanohydrin derivative. Suppose here CH3, then CH3, here is a Cn and OH, right? This, and after the disconnection what is going to happen, this form as a double bond and this Cn minus. In short I am showing over here CH3 C, then CH3 double bond O and plus Cn minus, and this Cn minus is nothing but as a synthon over here. Synthon means what? Synthon are the fragment of molecule which are associated with the polarities is known as a synthon. Means after the disconnection whatever species are obtained, positively or negatively charged species are called as a synthon. This is the simplest definition, or these are the example, suitable example from that we can got as a concept of synthon. What do you mean by the synthon? Synthon are the after the disconnection, after the fragmentation, whatever species are obtained, positive species or negative, that type of the thing is called as a synthon. Understood this concept? What do you mean by the synthon? And now the sixth one we are going to learn. What is that? Se called as a synthetic equivalent. This is known as a synthetic equivalent. Synthetic equivalent. Se is known as a synthetic equivalent. The synthon carrying the function of the reagent, or what we can call it as a reagent carrying out the function of synthon, is known as a synthetic equivalent. So that is a example of that synthetic equivalent. What do you mean by the synthetic equivalent? So synthetic equivalent, just now we have seen these are the synthon, and these synthon must have a synthetic equivalent, and synthetic equivalent are shown by these three lines. This clearly indicate here is a SCN, and this hydrogen cyanide or sodium cyanide is nothing but as a reagent, or the synthetic equivalent we can call it. Or here is a positive charge, and if you see over here CH3, then here CH3, another CH3, if you attach as a chlorine atom, so that is the synthetic equivalent. This one synthetic equivalent we can call it as here. So this is a synthetic equivalent for this synthon. So that type of the concept, a reagent carrying out the function of synthon is known as synthetic equivalent. So in this way you have to remember these are the example, or let me give one more example here. From that you can easily understood what do you mean by the synthetic equivalent. Let us say here pH, then CH2, then CH, here C double bond O, OET, then C double bond O, OET. This you imagine this is our target molecule. Let us see, this is a target molecule. Target molecule means what? Whose synthesis being planned is called as a target molecule. Now after, and as we know that first step always is a disconnection. Remember, in the retrosynthetic analysis first step must be disconnection, and as we know that disconnection means what type of the symbol, what kind of the arrow generally we are representing. There is a this one, that is a synthetic arrow, or a disconnection arrow. Disconnection means what? the analytical operation which break a bond and convert a molecule into a convenient an analytical operation which break a molecule and which break a bond which help us to reach the reactant starting from the target molecule is known as a disconnection. And now we are suppose I am breaking this bond over here, and this arrow also represent, this is a disconnection arrow, this curve arrow also suggesting that the bonding pair goes along with that carbon, and hence we are getting here this type of the fragmentation, that is a synthon we are going to get here, pH, then CH2, CH2 and then CH, C double bond O, OET and C double bond O, OET. Here now when I am showing as an arrow like this, both the electron going along with it with this carbon atom, and it has a negative charge. Ultimately, when both the electron goes along with this carbon atom facing, there is a electron deficient in nature, that is a positive charge. And if you look at this fragmentation, one is a positive, another is a negative, that type of the species are known as a synthon. These are the synthon, right? Both are the synthon, as we know that. During this, we have known that synthon means what? After the disconnection, whatever charge present, whatever fragmentation we are getting, that fragmentation means synthon are associated with the polarities are known as a synthon, and that synthon generally, synthons are the must have a synthetic equivalent, because synthon are highly unstable in nature. They are trying to stabilize this, and they are trying to stabilize, so they must have a synthetic equivalent. And just now we have learned about synthetic equivalent. What does it mean? Synthetic equivalent means what? The reagent carrying out the function of synthon is known as synthetic equivalent, and therefore whenever there is a positive charge present on that carbon atom, always think you have to bring, you have to insert, you have to connect the atom in a such a way that that atom should be the halide. As we know that the tendency of that halogen atom, they are more electronegative in nature. When they are more electronegative in nature, when we are going to attach when that carbon atom carrying as a positive charge, that polarity remains, that electrophilic nature remains as it is on that carbon atom, and that's why you have to bring the atom, you have to bring the halide atom specifically over here, pH, CH2 and that Br. When I am attaching Br, what is this species obtained? What is this compound? This we can call it as a synthetic equivalent. Understood the meaning of that? Synthetic equivalent means what? Synthetic equivalent, these synthon are highly unstable in nature. While we brought here bromine atom, you can attach iodine, chlorine, fluorine, but halogen atom, we know that the periodic table, in the periodic table, halogen family member, everybody knows that they are present near the inert gas element, or the what we can call it as a near the noble gas element, and those are fluorine, chlorine, bromine, iodine and the astatine. So astatine we are not including here because it is a radioactive. Radioactive means what again? Those the element having their atomic number greater than 82, they are the radioactive element because they are emitting alpha, beta, gamma type of the radiations over there. So we are not going to go on that way, but here I am trying to explain what do you mean by the synthetic equivalent. So this is a synthetic equivalent, and for this synthetic equivalent you have to attach there only as a hydrogen atom CH2, C double bond O, OET, and then C double bond O, OET. This is nothing but as a malonic ester, and we know that malonic ester, it is it is nothing but as a synthetic equivalent, right? Synthetic equivalent or the synthetic reagent, we have used this, its application. Number of application we have learned in a previous lecture or in a previous chapter, I think, and there how it is playing as an important role, why it is a versatile synthon, variety of the organic compound we have prepared by using as a this malonic ester. By using as a base we can form as a carbanion, and that carbanion is a either way. If you alter this the position of, if you put as a negative here, positive here, is it possible? No, it is not the possible, because we are thinking logically. Your logic, why if you put here is a negative, you can bring there is a Grignard's reagent is a synthetic equivalent, but here positive is highly impossible, and therefore you should not put the positive charge over here. If you put as a positive charge, that species are highly unstable. You cannot generate their electropositive species, because that is a highly reactive methylene group. And what does it mean? What do you mean by the reactive methylene group? At the in the chapter number 1, we have learned about the reactive methylene group present in malonic ester, as well as reactive methylene group is present in the acetoacetic ester or ethyl acetoacetate or a beta keto ester, and during that time we have learned how they are used as a synthetic application of those reagents. So now here I have explained these terms. What do you mean by the synthetic equivalent with the help of some example? I hope you all have got the concept of a synthetic equivalent. Now let us move on to the next point, next term, next important term, its definition. Let's see over here. Next term we are going to see over here, that is a 7th number, that is a reagent. R is called as a reagent. And I think most of you are familiar with this word. R means reagent, but most of you might not knowing the authentic definition of that reagent. So let us see what do you mean by the reagent. Reagent means what? A compound which react to give a target molecule, intermediate or target molecule itself is known as reagent. A compound which react to give an intermediate in a planned synthesis or to give the target molecule is known as the reagent. And here that it is called as a target molecule. 2 moles of ethyl acetate condensed in a presence of base sodium ethoxide reagent to form the acetoacetic ester. For example, we have reagent. For example, in a collagen ester condensation, we have synthesized the acetoacetic ester. Remember, do you remember this one? Most of you might be remembering. There we are using 2 moles of ethyl acetate C double bond O OET. Then we have used there NaOET, sodium ethoxide. The sodium ethoxide is nothing but as a reagent, or you might be knowing this CS3, then CS3 chloride. Here we are using sodium hydroxide, and these are sodium hydroxide in a SN1 reaction. We have used this and we got the tertiary alcohol CS3. Then there is a CS3OH, and this sodium hydroxide is nothing but as a reagent. Here the sodium ethoxide is a reagent over here. So these are the examples. CS3, then what we got over here, C double bond O, then CH-2, C double bond O, OET. This type of the compound we got. This is acetoacetic ester, right? So this is the term generally we are using in the retrosynthetic analysis. Now the final term, important term, it's a definition, and the definition, and with the help of suitable example I am going to explain that one also. Now is a 8th one, that is called as a FGI. And do you can you tell me the full form of FGI? The full form of FGI is a functional group interconversion. The full form of that FGI is a functional group interconversion. So that is the meaning of that FGI. The full form of FGI is a functional group interconversion. So now the definition. Listen the definition carefully here. Functional group interconversion means here one of the functional group converted into another functional group so that disconnection becomes possible is known as functional group interconversion. Understood this one? Functional group interconversion means what? One of the functional group is converted into another functional group so that disconnection becomes possible is known as FGI, or the functional group interconversion. Let me tell you here one example. Suppose you have a pH, then here pH you know that phenyl group, then pH CH2, then CH2 here maybe as a Br, right? This is our target molecule Tm. This is a target molecule, remember, and this target molecule, can you prepare this target molecule? So some of you might be preparing this target molecule, but let me tell you, those are not knowing, they can do the straightforward disconnection arrow, and then on a disconnection arrow FGI is written over it. That is the general way of representing functional group interconversion. Generally we are writing the disconnection arrow and FGI written over it. That is the usual way of representing functional group interconversion. And now here is a halide group, right? Now this halide group we can easily convert into another one, CH2 and the OH. What I did over here I have converted that halide group into as a alcohol. Once you got as a alcohol, that see that molecule, that target molecule, there is alcohol. What kind of the alcohol it is? It is a primary alcohol, and we can easily disconnect it by using the disconnection arrow, and after that you will get as a fragmentation of that. So that type of the thing is called as a FGI, functional group interconversion. I think with this we have learned all those 8 terms which are important one, 8 terms which are frequently used in retrosynthetic analysis. I think with this let us stop today here. Thank you. Have a nice day.